Most dog owners are familiar with the phenomenon of localized, persistent proximity seeking, a dog shadowing its owner from room to room, matching their pace and closely tracking their movement across the house. The common assumption is that this behavior stems from a psychological deficit. We project human neuroses onto the animal, labeling the continuous following as clinginess, anxiety, or a lack of confidence. The biology suggests otherwise. This persistent shadowing is a highly adapted, multisensory survival mechanic operating exactly as designed. Misclassifying this spatial tracking as mere dependency is a disservice to the animal. It prevents us from recognizing the sophisticated cognitive system a dog deploys simply to walk behind you. To decode this behavior, we have to examine the canine mind through three distinct scientific lenses: evolutionary biology, cognitive prioritization, and olfactory processing. The modern domestic environment, with its steady food supply and temperature control, presents a stark contrast to the conditions under which wild canine behavioral algorithms originally evolved. In this schematic of spatial tracking, the canine maps its exact position against a specific anchor, the human. As the human moves, the canine brain calculates an invisible metric of acceptable distance. The physical gap fluctuates, but the tracking ensures the threshold is never broken. This spatial tether provides the bedrock of canine psychological security. To understand why a modern dog operates this way in a completely safe living room, we must first reverse engineer their wild survival baseline. The primary axiom of wild canine ethology is straightforward. Physical proximity to conspecifics, members of the same species, directly dictates survival probability. This node graph illustrates a pack in a predatory environment. The rules are binary. Closeness generates safety. Distance introduces risk. The pack maintains a tight radius. Breaching that threshold strips away protection. The isolated node becomes vulnerable to threats. Domestication shifted the physical environment from the forest to the house, but the proximity algorithm itself remained intact. Over thousands of years, the trusted humans served as the functional replacement for the complex pack structure. The safety calculation collapsed onto a single central anchor, re-establishing that ancient security radius inside the domestic floor plan. Shadowing, therefore, is an ancient life-or-death survival algorithm executing itself within a modern, low-threat topography. Tracking a specific human requires significant processing power. The canine brain must constantly filter out enormous amounts of competing environmental noise to maintain the connection. Cognitive research from 2020 confirms that dogs process owner-specific information using distinct neural pathways compared to generic stimuli. Consider this schematic representing the baseline resting state of a dog's brain when exposed to standard household activity. The ambient noise of the environment registers as a steady, low-level pulse. To function effectively, the brain engages in stimulus filtering, an active suppression of irrelevant data designed to isolate high-value targets. The exact moment the primary human moves or speaks, the filter catches it. Specific neural regions sharply illuminate, contrasting the targeted stimulus of the owner against the cool ambient background noise. This selective attention is entirely asymmetrical. A dog evaluates the humans in its environment and assigns primary security status to one specific individual. The animal learns exactly who provides reliable comfort, regulates their feeding schedule, and consistently anchors their environment, locking in that target. Shadowing demands a massive, targeted cognitive investment. The sheer volume of neural resources required for this focus identifies shadowing as a signature of secure attachment. This cognitive mapping is reinforced by olfactory processing. Human scent functions as a regulatory signal, providing active chemical reassurance. This leads to the establishment of emotional territory. Dogs deliberately seek out scent-dense zones to build localized perimeters of baseline security. Look at this topographic map. To a dog, a domestic space is mapped by invisible gradients of the owner's scent. Areas like a favorite armchair or a jacket become concentrated pools of familiarity, leaving the rest of the room cold. A dog resting on their owner's belongings is embaying themselves within a chemical safety zone. Every instance of shadowing represents an ongoing, continuous cost-benefit analysis performed by the animal. Moving from room to room carries a bioenergetic cost. Breaking a resting state to physically track a human requires the active expenditure of calories and metabolic energy. This flowchart illustrates the decision tree a dog faces when a human leaves. The algorithm weighs the biological desire for rest against the evolutionary drive for spatial proximity. In a securely attached animal, tracking consistently overrides conserving energy. Every instance of shadowing is an active expression of this biological priority. Proximity is maintained at the direct expense of physical rest. True dependency is often passive, characterized by a lack of agency. Canine shadowing is an active, persistent behavioral choice that requires continuous energy, confirming a highly secure attachment. A simple walk down a hallway masks a vast biological architecture. This composite visual shows the intersection of these overlapping systems. Evolutionary proximity algorithms, neural stimulus filtering, and olfactory mapping operate simultaneously, continuously processing environmental data to secure the animal. This multi-layered processing network forms the true biological architecture of the canine-human bond. Because this high-energy behavior serves as the baseline state for a securely attached dog, its sudden absence acts as an urgent signal. This brings us to the diagnostic baseline. A dog's consistent, historical behavior serves as a vital medical benchmark for their overall health. As we see the tracking lines snap in this diagram, it represents a critical anomaly. If a previously proximate dog abruptly stops shadowing their owner, that fracture in routine is a direct warning sign that must not be ignored. A behavioral break of this magnitude is typically rooted in physical realities. Acute physiological distress, cognitive decline, or hidden pain will eventually force the animal to override the proximity algorithm to conserve energy. Owners often misinterpret sudden independence in an aging dog as a natural shift in personality, assuming the animal has simply outgrown a needy phase. A dog's physical proximity is a continuous stream of diagnostic data. It operates as an expression of profound trust and ongoing communication. By constantly monitoring this baseline, we can truly protect the animals that spend their lives tracking us.